here. The second one is more complicated. It's a manganese, or I can say, first of all, please write down the number first, oxidation number, and color. Now, all these three stages, you can get the color easily because we have learned this before, right? This one, we learned this before. MnO2 is not something new because when the potassium permanganate solution in alkaline condition, they will form black or brown solid. This is MnO2. The substance that you don't know is green for positive 6 and brown for positive 3. So again, no worry because I don't think the exam will ask you something like this. If you can remember, very good, but if you cannot, take it easy. The following is more important. The first one is, how come Mn2 plus is formed? Yes, from acidic condition. So still remember the half equation, right? Next one, how come MnO2 is formed from the permanganate is in alkaline condition? So again, started with MnO4 minus, ended with MnO2. Now, no need to memorize the equation actually. Let me show you how we can do it by using ECHO, ECOH, okay, in the draft. Step 1, just forget that this is an acidic condition, okay? Just forget it first. So I use the original method, 2 oxygen, 4 oxygen. So I add 2 water here and 4 hydrogen ion here. And finally, 3 electron here. Well, this is what we done before. Step 2 is, because there is alkaline condition, so no hydrogen ion should be left here. In both sides, I add 4 hydroxide ion. Finally, like this is step 2. And sure, step 3 will be cancel out the excess water, right? And you will get the answer. So let's copy it down. Okay, I think this is more important than memorize the color of different ions in manganese. Alright, it's your turn. So please try this. So for this checkpoint, so you will ask about the color of the solution for 3 different types of manganese ion. And I think there is a typo here, right? It should be MnO4 minus. Alright, so sorry for that. Right, if there is MnO4 minus, so I think everyone can get the answer easily, right? It must be purple. For Mn2 plus, it must be colorless. So very good. We find the answer is D. Next one is again ECS. So here shows you which of the following reaction can occur spontaneously. Now, spontaneously means automatically. That means you don't need to keep input energy to that. If you still have no idea, so give you an example. Displacement is a spontaneous reaction. Chemical cell is also, but electrolysis is not. Electrolysis, we need input energy continuously. Well, otherwise the reaction will stop, right? So the key for spontaneous reaction is anti-clockwise relationship. That's it. So let's start. The first one is zinc and water. Alright, zinc and water. Oh, sorry to say, this is not anti-clockwise. The second one is scandium and chromium 2. So let's see, scandium is here, chromium 2 is here. It looks good. What about the third one? Is titanium 2 and vanadium. So again, let's double check. Titanium ion is here and vanadium is here. So no anti-clockwise relationship. Finally, is what about copper and nickel 2? Now nickel 2 is here, copper is here. So again, no anti-clockwise. Sorry for that. So the answer is easy, right? It must be B. Well, next one is the final characteristic properties for transition metal. It's called catalytic properties. Again, I will say this is one of very important properties because you never learned this before. They can serve as a catalyst. Yes, and here I will try to introduce three processes. First of all, I think this is highly important. It's 5 stars. It's called Haber process. This is important because this is one of the core material in your book 6 in grade 12. So you should not ignore this. At this moment, you need to learn is it turn nitrogen and hydrogen into ammonia. Second one is it use iron as catalyst. All right, stop. We will go further in book 6, okay? That's it. The second one is try to produce SO3 from SO2 and oxygen, and we use vanadium 5 oxide. Again, that's it. But normally, some of you may wonder, sulfur can form SO2 and SO3, but how come we seldom find SO3, for example, burning fossil fuel? How come we cannot form SO3? Because if SO3 is formed, it is used to make sulfuric, oops, the word is missing. We can dissolve SO3 to form sulfuric acid directly. It is wonderful, right? One of the air pollutants now become the resources of making sulfuric acid. But in fact, this will not happen because SO2 is more stable. So we need catalysts to lower the activation energy. And all you need to learn is during the process, there is change in oxidation number to form intermediate. But don't worry, as we have learned before, finally, the catalyst will be regenerated. It remains chemically unchanged after the reaction. That's why they will not consume. And something is more, is after we prepare ammonia from Haber process, how to turn it into nitric acid. The reaction between ammonia and oxygen will form NO and water. With this one, we use potassium catalyst. That's it. Forget about the rhodium. In this equation, there is something interesting. This is what we call 4546. Every student who study chemistry in Hong Kong, when you ask them, do you know what is 4546? They will tell you the answer. Is convert ammonia into NO for making nitric acid. 4546. So here shows these are the topic exam questions. Try it by yourself first. This is easy, right? Sure, they can form catalytic compound and they got variable oxidation state. They got catalytic properties. All these three are the core in this unit, right? I still remember I have mentioned. But what about the reaction with hydrochloric acid? Well, many metal can do it. Zinc can do it. Magnesium also can do it. But don't forget magnesium, calcium, they can do it, but they are not transition metal. So this is not the characteristic properties because other metal can do so. The challenging one you have come across in the unit about electrolysis, so I don't repeat anymore. Finally, you can see, use iron as an example to give me two characteristics of transition metal. Let's write down. For transition metal, first, double check 1, 2, and 3. Still remember? Let's copy down. The first one is form colored iron in aqueous solution. The second one is they got variable oxidation state. The third one is catalytic properties. Right. So let's use iron to fit in. The first one is, yes, easy. Iron 2 aqueous is pale green. We finish. The second one is iron form iron Fe2 plus and Fe3 plus. They can have different oxidation state. Finally, catalytic properties. Yes, here shows iron is used as catalyst in Haber process. You finish the job. So that's why only 2 marks will be contributed, because this is not difficult at all. Some of you mentioned you want me to discuss this with you. Okay, question 2. So please, again, this is a wonderful question, so please complete it before listen to my explanation. We have this number of mole of chromium iron, but I have no idea what N is. And we got this amount of permanganate iron. Alright, so it was found that 48 cm³ of permanganate solution is needed to oxidize this amount. Alright, so first of all, half equation for the permanganate iron, well, easy. Here shows. I'm sure you have done this many times before, right? Well, the second one is a bit complicated. Don't be scared by the unknown N, because information is given here. For manganese, +7 to +2, easy. For chromium, +N to +6, it sounds good, because the chromium N plus finally will become dichromate. So this is our old friend with +6 oxidation number. Okay. Now, as I mentioned, no need to be panicked. Do it one by one. First of all, balance the number of elements. The echo ECOH, right? There are 2 chromium on the right, so there should be 2 chromium on the left. The second one is balance the number of O by adding water. So there are 7 O, so I should have 7 water. Then the hydrogen ion. Well, altogether there are 14 hydrogen ion like this. So finally is the number of electron involved. Now, just be careful, it's okay. Right, for the left-hand side, the total charge is +2n, right? But on the right-hand side is, at this moment, the charge is positive, right? In order to, don't forget, electron get negative charge, okay? Electron get negative charge. So, first of all, as a oxidation, because for permanganate, it serves as OA already. That means the chromium ion should serve as RA. So the electron should be added here. Understand? The second one is +12. Add Y electron, that is -Y in charge, will equals to 2n. This is balanced charge for the right-hand side and left-hand side. Simple 12 minus 2n. Good. So here shows. Understand? Next one, reduce the number of chromium ion oxidized by 1 mole of permanganate. If you have no idea, find the number of mole first. number of mole of permanganate iron used. Easy. M times V, right? Here. Good. But at the same time, we have this amount of chromium ion used. So number of chromium oxide by 1 mole MnO4 ion is here, equals to 1.25. Each mole of permanganate ion can finish 1.25 mole of chromium ion. 1.25 mole. The next one, try to deduce the number or the value of N. So in order to solve these questions, we need to rewrite the equation in A2. We change it into the coefficients of chromium ion into 1.25.
So now the new equation, let me rewrite. By times a suitable factor. Now the coefficient of chromium ion is 1.25, matched with the one in A1. Now the mole ratio between permanganate ion and chromium ion will be 1 to 1.25. The new equation becomes like this. But the critical part is how many electrons we got. So here, let me calculate. So finally, I need 7.5 minus 1.25 N electron. Now this equation is critical. With the balanced equation, we can compare the number of electrons on both sides. They should be equal, right? So we got it. N equals to 2. This is the answer. So for those students who are weak in math, so try to redo it by yourself, and I'm sure you can do it well. So if you got any questions, so please ask me. See you next time. Bye bye.